Let's find the square root of a matrix. So before we begin taking the square root, it's necessary to know some basics about how we raise a matrix to any n power. And if you know like something about that, you can just skip a few minutes ahead because I'm going to start from the basics. So the first thing that if you want to raise a matrix to the power any n value, the first thing we want to do is to express this in the form of P D P inverse, where D is a diagonal matrix. Yeah, that means all other elements other than diagonal elements as 0, and P is any other random matrix. So basically, we will be able to express this matrix 2, 2, 2, 2 as 1 minus 1, 1, 1. Yeah. And then 0, 0, 0, 4. And then 1 minus 1, 1, 1 inverse. I will tell you like how do we find these other matrix P and P inverse, and also how to find this matrix D. Yeah, but first of all, I will also want to show you like after finding this P and P inverse and D, how is it helpful for this form to find a to the power n. I want to show you that first. So let's say we find P, D and P inverse as a product for A. Now if we find that, now A square will just be P D P inverse times P D P inverse. Yeah. Now since matrix has associativity property, we can write this as PD and times P inverse P and then DP inverse. Now P inverse is just I, and I times another matrix is the same matrix. So now this is PD, and then I times this is just DP inverse. Again using associativity, we can merge D and D. That gives us PD square P inverse. Similarly, if you want to find A cube, we can just merge PD square P inverse with A again, PDP inverse, and that again gives us P D cube P inverse. This tells us that if you want to find a to the power n in this form, a to the power n will just be P D to the power n times P inverse. Okay, so we know this, but how is this helpful? But we still need to find d to the power n, and wouldn't that be tough again to find d to the power n? The answer is no. To find d to the power n, it won't be tough. Let me show you how. Let's say you want to find d square. That will just be a00b squared. That means multiplying it twice, we have a00b. Now if you try to multiply this, you will see that it's really simple. A0, that means a square. A0, 0b, that is just 0 plus 0. 0b, A0, 0 plus 0. 0b, 0b, b square. You see? Now if you want to find d cube, just multiply this d square with d again. Yeah. So you will get a square 0, a0, a cube, a square 0, 0, b. Sorry, a square 0, 0, b. Yeah, that's just 0. 0 b square a 0 is 0, 0 b square 0 b cube. So you see that it's really easy to find the powers of d, because d to the power n is just a to the power n 0, 0, b to the power n. So you see that. So that's why let's say if we write A as P and then a diagonal matrix A0, 0, B and then P inverse, if we want to find A to the power n, we can just do P A to the power n 0, 0, B to the power n P inverse. Now we just derived the formula for n as an integer right now, but even if it was any other numbers other than integer or any real number, we can still do the same thing. A to the power 1 by 2, 0, 0, b to the power 1 by 2, p inverse. So this is the main gist on how we are going to find the square root of a matrix. Yeah, so I think you got the overall idea. Now the only problem is to find how to find the diagonal matrix and the P matrix. Yeah, so for that we actually need the concept of eigenvectors and eigenvalues. We need eigenvectors and eigenvalues, and I will introduce that slightly, yeah, like according to how much you need, and I think that would be enough. So I'm not really going into a lot of details, but let me tell you that basically, let's say if D is for this matrix A, for the matrix A being 2, 2, 2, 2 or something like that, for any matrix A, if D is A, 0, 0, B, then actually A and B are just the eigenvalues of matrix A. And I will tell you how to find the eigenvalues later on. And then, since you will be able to find eigenvalues, diagonal matrix will just be eigenvalues in the main diagonal and all other elements 0. So A and B are eigenvalues of matrix A. So that's how you find diagonal matrix. If you want the reason like why the eigenvalues are there in diagonal matrix, you can probably Google, or I will also link some articles in the description, and that's somehow beyond the scope of this video. And to find the P, now if P is A1, A2, B1, B2, let's say, if this is our P, now A1, A2, A1, A2 and B1, B2 are just the eigenvectors of matrix A. Eigenvectors. So there are basically uh, two distinct eigenvectors and two distinct eigenvalues. Then we can have diagonal matrix and the P matrix, eigenvectors of matrix A. Now let me show you how to find the eigenvalues and eigenvectors of matrix A. So this is, we are going to go into a whole new world of eigenvectors and eigenvalues, and then after we are able to find those two things, then it's a really easy stuff to find the square root, because I have already told you the basic idea. Now let me show you how to find the eigenvectors and eigenvalues of a matrix. And for now, the matrix is 2, 2, 2, 2. Okay. So let us first go in definition. So let's say the eigenvectors of this matrix are represented by B and eigenvalues by lambda. In that case, basically these things are defined by, if a matrix A is multiplied by the vector B and the result is lambda times B. So if this is true, in this case lambda is called as eigenvalue and B is called as eigenvector. Okay. Now if this is the case, let us manipulate this equation so that we will be able to find the eigenvalue and eigenvector. So if we take lambda b to other side, we will have something like this. Now if you want to take b common, yeah, now to take the b common, we need to have a minus lambda, yeah, but lambda is just a scalar quantity. Yeah, so how do we change the scalar to a matrix form? So let's say we know that 1 is basically 1, 0, 0, 1 in matrix form. Yeah, that's why if you want to find lambda, just multiply lambda by 1. That means it will just be lambda 0, 0, lambda. That means lambda times I vector. Yeah, so lambda times I vector b equals to 0. Okay, so now we are basically assuming that like we have a eigenvalue, yeah, and also eigenvector. And eigenvector, note that eigenvector, if it's 0, it's trivially true. So we are saying that eigenvector should not be 0. Yeah, but eigenvalue, this can be 0. Okay, please note this thing. Okay. So now we are assuming these things to be true, yeah. And now we have reached this equation. So now in this equation, if a minus lambda I has an inverse, we can write this equation as v equals to a minus lambda I inverse times 0. But now multiplying by 0, this will just be 0. And this contradicts our assumption because we are saying that v should not be 0. And we got the v to be 0. So that's why what this implies is, what this equation implies is a minus lambda I does not have an inverse. Does not have inverse. Okay. And so that's why if a matrix doesn't have inverse, we can also say that the determinant is 0. Yeah. If determinant is 0, then doesn't have inverse, and the same thing in the other way as well. So this is the condition. We got a condition to find lambda now. So using this condition, we can find the lambda. And once we have lambda, we can again use this equation. A minus lambda I times v equals to 0 to find the possible v's that makes this matrix 0. So let us see the example of our own matrix, and you will be further clarified how to find eigenvectors and eigenvalues. Yeah, these two are the equations that we need. So let's say our A is 2, 2, 2, 2. Yeah. Now what do? We find determinant of 2 minus lambda I. That means determinant of 2, 2, 2, 2 minus lambda I is lambda 0, 0, lambda. This should be equal to 0. That means determinant of 2 minus lambda, 2, 2, 2 minus lambda. This should be 0. Yeah. That means if we take determinant, we have 2 minus lambda whole square minus 4 equals to 0. That means lambda square minus 4 lambda plus 4 minus 4 equals to 0. 4 cancels out. So lambda times lambda minus 4 equals to 0. Yeah, so lambda equals to 0 or 4. These are our eigenvalues. So that's why, since we have eigenvalues, now you can say that our diagonal matrix is 0, 4. Yeah, the diagonal element is the eigenvalues, and then others are just 0, 0. Yeah, is this the one that we wrote earlier? Yeah. Now let's find the eigenvectors. We know that eigenvalues are 0 and 4. Now to find the eigenvectors, let's say let us try to find the eigenvector when lambda is 0. Yeah, in that case we need to have a minus lambda I times b equals to 0. Yeah, and a is 2, 2, 2, 2, and lambda is 0, so basically it will just be 2, 2, 2 again, 2, 2, 2, 2. And let's say lambda, our eigenvector is xy. Yeah, and why 2 into 1 matrix? Because we basically earlier had AB equals to lambda V. Yeah. Now, so basically our eigenvectors are basically in the form 1 by 2, and this is also 2 into 2, and so if it is 2 into 1, then we also get 2 into 1 over here. So that's why. Now and it's also defined as a column vector. Yeah, so that's why. Now equal to, this is just 0, 0. Now we have 2x plus 2y equals to 0, 2x plus 2y equals to 0. Yeah. Now the most basic solution for this is x comma y being 1 comma minus 1. Yeah. And there are also other solutions like minus 1 comma 1 or 2 comma minus 2. Those will also work, but we can take this one as well. Now when lambda equals to 4, we have a minus lambda I times b equals to 0. Yeah. Now we have lambda as 4. Yeah. So we will have basically 2 minus 4. Sorry, no, not 0. So 2 minus 0 over here. 2 minus 0. 2 minus 4. times xy is equals to 0. Yeah, so now we have minus 2 2 minus 2 times xy is equals to 0. So we have minus 2x plus 2y equals to 0, or 2x minus 2y equals to 0. That's why we have our eigenvector as xy, and this we can take 1 comma 1. Yeah, that will work. So we basically have now both the eigenvectors. So that's why now our p can be written as first eigenvector and then second eigenvector. So in this way we get the p. Yeah, so we have basically get both the p and d. The p was just both the eigenvectors, d was both the eigenvalues. Now we have both of these things. Now let's find the square root. It's time to find the square root now. Now we know that square root of a to the power 1 by 2 is just p d to the power 1 by 2 times p inverse. Yeah, and our p is 1 minus 1 1 1, and our d was basically 0 0 0 4. Yeah, so basically we will raise diagonal element to the power half, and then we have p inverse 1 minus 1 1 1 inverse. Okay, now let's do it here. Now if you take the square root, what do we have? 1 minus 1 1 1, and then 0 0 0 2, and then now to find its inverse, 1 by determinant is 2, and then interchange this to 1 1, and then negate this the other diagonal minus 1 1. Yeah, now let's multiply 1 by 2, 1 minus 1 1 1. If you multiply these two, we get 0 0 2 2. Is it 0 0 0 2 2? Okay, now again multiply these two, we get 1 by 2 times 2 2 2 2. Is that it? Is it? Let me check if we are doing. Let me check if I'm doing it right or not. Basically, first of all, we have 1 by 2. Let me do it first, but I'm not really sure if. Okay, so we get 1 1 1 1. Yeah. Now let's try to square 1 1 1 1, because if it's the square root, like we should be able to square and get the original value. Okay, so 1 1 times 1 1 is basically 2. 1 1 times 1 1, that's 2. 1 and 1 1 is 2. 1 is 2. Yeah, so we got that value. So yeah, you can see that we basically found the square root as 1 1 1 1, and that was it. That was kind of trivial, though I did not see it at first. But now after doing the multiplication, it feels trivial that this should be the answer. Yeah, and now we have finally found the square root. So if we have to talk about the flow, I first try to give you the idea of how this form is helpful, how this form helps to find the nth power, and let me go give you a bonus as well. So if you are trying to find, let's say, e to the power a, in that case also we will have p times e to the power a 0 0 e to the power b times p inverse. Yeah. Now you can find a proof in a video in my playlist over here in the second video. Like also if you want to take log of a, the proofs are also easier. That's the based on same approach. So log of a 0 0 log of b, and these things are really like wow sort of things, because you can raise matrix to a power, you can log a matrix, also matrix to matrix power, matrix the root of matrix power. All of those are possible with this idea. All the videos are there on my playlist, you can check them. Yeah, and okay, so let's talk about the flow. So basically I gave you the idea about how to raise to nth power, Yeah, and then I showed you how like raising power of a diagonal matrix is easier. Yeah, and then I showed you like how will we get our answer at last. Yeah, and then I tried to show you about how to find the eigenvalues and eigenvectors. And after finding eigenvalues, eigenvectors, we had our P and D, and then we found inverse, multiplied, and we got the square root. So this was all about finding the square root. This captures it all. Yeah, and yeah, you can take a screenshot if you want. And hope you enjoyed the video. And also check out the videos on exponentiating a matrix, taking log of matrix, matrix to matrix power, matrix to root of matrix, and other videos on my playlist. And do enjoy those videos. Thanks for watching. Look forward to seeing the upcoming videos too.